Hope you're having a really great, wonderful Wednesday evening. And tomorrow is Thursday, so go Bearcats. All right, we're in Precal, of course, and it's going to be day 1 of 10.1. 10.1. We're talking about mathematical modeling and variation. Tomorrow when you come in, please grab a graphing calculator, and we're going to talk about how to do regression again in your calculators. We haven't done that in a while. You probably did that in Algebra 2, but I want to go over the calculator part with you in class tomorrow. So when you come in, go ahead and get a graphing calculator, and we'll do problems 1 together in our textbook, and then you can practice on number 7 tomorrow as part of your classwork. The next thing we're going to talk about tonight is variation. And you did do variation last year in Algebra 2. And I've got some notes for you tonight and a couple of examples, but mainly some notes. All right, the first thing we're going to do is we're going to talk about direct variation. Oops. We're going to talk about direct variation. Direct variation is very similar to like your linear equation when your slope. It's very similar. If you kind of think of that, it'll help you keep things straight. Often you'll hear terms such as y varies directly as x when you're reading an application problems. Or you may hear y is directly proportional to x. And this is the little formula, y equals kx. I'm going to write up here, y equals kx, where k is a constant. Sort of like y equals mx, well, m is a constant as well. It's a constant slope. K can be a different kind of constant, but it is a constant. And k is called the constant of variation or the constant of proportionality. So just so you have that information, you definitely want to pause the video tonight and take these notes down. And tomorrow when you come to class, in a few minutes, I'm going to tell you what I want you to bring to class in a little piece of paper and hand me tomorrow. That's how I'm going to know if you watched the video. So there'll be like a code word tonight in the video, and I'll tell you that in a few minutes. All right, let's look at an example for direct variation. Here would be an example of how it's worded. It says y varies directly as x. And so you're going to all of a sudden write that equation down, or that formula down for variation. Y equals k. And then it's going to give you some information. And we're going to find a mathematical model that gives y in terms of x when you have certain given information. So we're going to plug in. It tells us that y is 15 when k is, or when x is 3. When x is 3. And the first thing we're going to do is we always are going to, so we're going to plug in, so plug in. The next thing we're going to do is we're going to solve for k. The next thing we're going to do is we're going to solve for k. Okay, so let's do that next. Way to do that, to solve for k, you're going to divide by 3 on both sides. And of course, the k, 3 will be gone, and this should be 5. So k equals 5. You just solve for the variable k, which is your constant. It's really not a variable, I apologize, for the constant k. So our constant, k, is equal to 5 in this problem. All right, and now we're going to go back and write y in terms of x. So it's kind of like if you find the slope and then you go back and write y equals 4x because 4 would be your slope. Same thing. We're going to write y equals 5x. And that is our equation of direct variation for this particular problem. So remember, k is a constant, so it's not going to change, although your x and y values could change. This would give you information along that looks like a line particularly, that would give you information along that line no matter what, but it would be on the same line because the constant is 5. All right, let's take a look now at inverse variation. That was direct variation. Let's take a look at inverse variation. All right, let's see. What could our code word be? I think our code word is going to be spring. Our code word's going to be spring because the Bearcats play spring this Saturday. So S-P-R-I-N-G would be the code word. So make sure tomorrow you just hand me a little piece of paper that says spring on it. All right. Plus, we're going to have a quiz tomorrow over the stuff that we did in the last few days. So don't forget that. All right, inverse variation. Inverse variation, we can have that written several different ways, and they're equivalent statements. You can say y varies inversely as the nth power of x. Or it could just be y varies inversely as x. You could say y is inversely proportional to the nth power of x. And again, it doesn't have to be to a power. It could be just inversely proportional to x. And in this particular situation, we have y equals k x n. And n stands for the nth power. N stands for the nth power. All right, so let's take a look at this example. I like to kind of rewrite that and make a little more sense to you. Is I would like to rewrite this as y equals, and it's going to be k over x. And it can be the nth power if we want, but it's just going to be k over x. That's our inverse variation. Well, ago we had k times x, and now we have k divided by x for inverse. Inverse, we inverted that original statement maybe. That helped you remember it. All right, y varies inversely as the cube, okay, as the cube of x. All right, when y is 54 and x is 3. Find y when x is equal to 2. All right, we got a lot of information here. So let's take a look at what we know. So y, let's talk about what the original equation says. Y varies inversely, so that would be k over the cube of x. So x cubed. X cubed. That's going to be the base equation that we start with. So next, we're going to solve for k again. So we're going to substitute in or plug in, and then we're going to solve for k. That's the same process that we just used. So, all right, same process that we just used. So let's plug in first. Y is 54 equals k, our constant, over x when x is 3, but it's going to be 3 cubed. 3 cubed. Well, 3 cubed is 3 times 3 times 3, which I believe would be 27. So 54 equals k over 27. If I want to solve for k, this time I'm going to multiply by 27 on both sides. And all of a sudden, 27 times 54 is 1,458, which equals our k. Our k is equal to 1,458. That's our constant. So we solve for k, our constant. Next, we're going to write our equation back. You're going to go back to this original equation, and you're just going to plug in the constant, and everything else will stay where it is. So when we do that, we're going to plug in y equals our constant, which is 1,458 over x cubed. And now we have our base equation that we can use, and we can find the other information. So now we want to find y when x is equal to 2. So we're going to say y equals 1,458 when x is equal to 2. So 2 cubed. 2 cubed is actually 8. So 1458 divided by 8 would be y equals, it's going to be y equals 182.25, or 182 and 1/4. And that would be solving for y. We found the value of y using the equation that we gave. Okay, again, you may want to pause and think about what we just did. You may want to try to do it on your own and see that if you could go back and follow the work to check to make sure it's correct. All right, we got one more little thing to go over. Don't forget our code word spring. Our code word spring. Okay, bring that to me just on a little tiny piece of paper, folded so nobody knows what it is. and hand it to me. Matter of fact, if you'll put your name and class period on it, maybe I'll just find a basket to put on my front table and just drop it in the basket. Okay, then everybody will be wondering what you're doing. I'll put a basket on my front table when I get finished right now, and we'll do that. Excuse me. I have a blue basket over there in my room. Okay, so code word spring. Just put that in there. Make sure you have your name and class period. Name and class period. And you can put just your last name and class period if you want, or both first and last is fine. All right, last we want to talk about joint variation. Joint variation, I always look at joint variation, it's just a lot of things join the party. Okay, so we already had something going on, and now we're just joining the party. So it's a bit like direct variation, except that more people have joined in on the party. So this happened to say that z varies jointly as the nth power of x and m to the power. Okay, they're just adding a lot of things here, but it's really the same basic equation. So when we originally had y equals kx, which was direct variation, now we just got more stuff going on. Now we don't have this, we have y equals k times x, and that could be to the nth power if we wanted it. We have a y, and that could be to the m power. And you can have more variables than that even. Okay, that's just a base formula for it, or base equation for it. All right, so let's take a look at this last example. And then don't forget your little piece of paper that says spring on it, and put it in the basket with your name, class period on it. Last name and class period. All right, here we go. Example. The volume of a right circular cylinder is jointly proportional. There's the word you're looking for. So you know it's going to be a constant times a bunch of stuff. So I'm going to go ahead and start setting this up, but I want to start using the variables in the problem. It makes it a little easier. So volume, whatever word comes first in your, introduced first to you in your word problem, most of the time, that is going to be like the y value of your equation. So I'm going to treat my volume, I'm going to use the letter V as my y value. So I'm going to say V equals, and I know K is a constant, so I'll have to find that out in a minute. What else? So the volume of a right circular cylinder is jointly proportional to its height and to the square of its diameter. To its height, okay, so height and the square of its diameter. It didn't say square root, it's square, so the diameter square. And that would be how we would set up our problem. All right, let's see what we want to do. So we have the equation. Now we're going to plug in. Now we're going to plug in. So let's do that. So the volume is 320 pi. 320 pi. We don't know the constant yet. When the diameter is 16 and the height is 5. So the height is 5 and the diameter is 16, but we have to square that number. So right now we have enough information to find out our constant. So let's do that next. So when we do that, we have 320 pi equals, and we have 16 squared times 5. 16 squared times 5 will be 1,280. So 1,280 K. And we still want to solve for K. So if I divide by 1,280, 1,280, this is going to be 1/4 pi. So 1/4 pi, or pi over 4, is going to equal my constant. That's going to be my constant. Next, I'm going to use my constant, and I'm going to go back to that original equation. I'm going to go back to this original equation right here, and I'm going to plug in what I found my constant to be. So my equation now will be V equals pi over 4 h times d squared. Okay, so you had to find the constant, then you go back to the original equation and you plug in the value of the constant. Now you can use this to find anything that you want to find. All right, what do we want to find? It says, what is the volume? So we're not going to know the volume. when the diameter is 10 and the height is 4. So pi over 4 is the constant, that stays. The height is 4 and the diameter is 10. Well, this is kind of easy. I'm going to put these over 1 and make them fractions. I don't have a calculator. I'm going to try to cross cancel. So my 4's would cancel and I would have 10 times pi. So my volume now would be 10 pi over 1 or just 10 pi. Oh, that was supposed to be squared. I kept thinking that was wrong. So 10 squared would make it 100 pi. Sorry, 100 pi. So our volume is 100 pi. So go Bearcats. And don't forget, code word, spring. Okay. In the basket when you come in tomorrow. I'm excited if you watch the video. I hope you learned a little bit about variation. We'll expand on that tomorrow and talk about regression in your calculators. Have a great evening, Bearcats. Night.